Thank you, Oscar. It was very good. So let me switch to the questions, and we get some interesting questions. But as all of us give you a different perspective, how companies has transformed from the stuff data-driven companies or data providers, analytics provider like mine, Ericsson or Docomo, as well as the research. I think there is an interesting question, which is also related, is and I want this for the sake of time to maybe switch to this question, is how we see the role of research as well as supporting research. Because to the sense, wireless and AI is very interesting, but we cannot do experimentations based on the sort of sample of the data. So there was a good number of questions asking how the researchers can get access to the data so they can do better research, but also for us to see how we could do more research, or how do we see a role of universities doing more research in this space. So with that, I will ask maybe Malik to give a short answer to how he sees this role in this.
Yes, certainly. Thanks, Arthur. I see two questions online, Eugen Ku as well as Tio asking. These are the two interesting questions they asked. That's where research can help. Let me repeat the question. One is about the delay and latency, about how can AI offer the delay and latency between the edge and cloud. That real-time edge inference is a key topic for us. How do we reduce that both training and inferencing to microseconds, at the most sub-milliseconds? I think that's where the research institutes can, like CWC, can help us developing such algorithms. Second thing that Tio asked is that, hey, there is a heterogeneity of platforms and frameworks in AI. How do we handle this heterogeneity? Do we need to have a hierarchical AI system? I think that's an excellent question. When it comes to compute platforms, we have TensorFlow, TPUs, GPUs, FPGAs, ASICs. When it comes to frameworks, you have TensorFlow, PyTorch, and so on. So that's where the CWC and UCSD can help us abstract the complexity of that heterogeneity. At the same time, help us realize some hierarchical federated learning kind of techniques to implement. So in summary, research can help us on heterogeneity side, real-time inferencing side, as well as how hierarchical federated learning can help abstracting the different actors, for lack of a better term.
Thank you. Babis, maybe your view on that, how you see this? And you are muted, by the way.
So I also see the question by Nambi Sesadri, which is related to all this, which is the need for data sets, right?
Correct.
So my view is, as I said earlier, it is really important. This Open RAN architecture will really enable us to do AI optimizations at every point in the communication link, every layer, right? Now, at the same time, as Malik said, we have petabytes of data coming at us, and it is challenging just parsing the data in real time. What we actually need, I think, is data sets, public data sets that are developed by experts, much like the other communities have done, like the computer vision community. You have also basically the performance metrics by experts, and they allow the research community to have a starting point and a direction to do some development of new algorithms, much like the way we had with model-based systems, right? Models came from physics and also from application requirements, and then they were disseminated to the research community, and then the research community innovated. So similarly here, we need the data sets and also the benchmarks in a way, much like other communities are doing. So that's kind of my view in this.
Very interesting view. So before I go to asking Oscar for his answer, I will give my perspective, as I come from the company which develop algorithms and deal with the data. The interesting part is we see the need for research in the space of how those algorithms could be applied on the real data. Because to your point, there are public data sets, but for example, if I combine wireless and medical data, industrial companies have no access to those data sets. Universities, they can. And they can build the models, train the models, which are not built on the samples of the data, but on the full data sets. I think also the very interesting element, which me and my companies we are looking to, is how we can apply heuristic modeling approaches. So how we can, instead of just looking at the knowledge-based system, also look at how the correlation of different variables is impacting the decisioning. And this is a very complex research which requires a lot of collaboration on the university side between the experts in wireless technologies to people working on the numeric methods, as well as the material design, and applying different simulation methods to see how we can export value of those petabytes of data. Because, as you said, we cannot compute those petabytes, but we have to find the right models for that. And I think there is a big thing which universities can help us to get to this, because they have access to the broader set of data. So that's my view. And with that, I will ask Bhaskar, what is your view as a university member? How you see the role of this, of how universities can help in the wireless, which I think will be interesting perspective.
Yeah, I think I'm glad actually Nambi asked that question because I think without data, there's not much you can demonstrate in terms of efficacy of machine learning. So, and one of the reasons may be that ML and communications have slow to adopt ML tools is because of the lack of data. I think the other areas have had plenty of data to work with. So one, of course, this would be a great development, I think, in terms of having standard data sets. Okay. And the other option, which I think maybe there'll be more experimentation from the university side. So I can see my colleagues building experimental test beds so they can collect data on their own. But again, this will still be, it would be good to have a coordinated approach so that more people have access to data on which they can actually demonstrate their algorithms. Arthur, did we lose you?
Yeah, so okay, that was good. So we have 5 minutes left. So I think that the interesting question, which I know is very broad, but if we can spend 1 minute answering, is we talk a lot about the evolution of 5G, 6G, but I think there is also a big evolution into the autonomous life. And it'll be interesting to see different perspectives, how you see the future or the big rocks which are going to move us from our current life into more autonomous life, where things are supporting us to make better decisions or even making those decisions for us. So with that, Babis, maybe let's have a 1 minute view from your side on that.
Yeah, so I guess regarding autonomous life, I'm by no means an expert to talk about this, but I can say a few things. People envision the network, in fact, in Docomo as well, to be part of the society in the future, managing our lives. And in fact, we have a lot of internal projects towards this. People talk about the Internet of Senses, connected intelligence machines, a network compute fabric, and so forth. So what I would say is I would point to a couple of things. Are we ready for autonomous life, right? So what I can say for a fact is all these sort of sensed awareness and proactive control in the network will be possible by exploiting heterogeneous data obtained from diverse set of sources. It's not just radio data, it's visual data, it's sensors, it's, as I said, surfaces, smart surfaces, and so forth. And of course, we need domain-specific AI tools, and the Open RAN will play a key role for this. At the same time, for the ready part, I guess the extent to which we will be ready or to what extent we'll progress will depend on the requirements of the specific applications, I would say. So take, for example, autonomous driving, right? This is one of the components of autonomous life. We're clearly not ready. We made great strides, but there's a long way to go. And frankly, the reason for that is, one of the main reasons is the accuracy bar is very, very high, right? So it's very challenging. However, as we move forward, what will help is the ability of future networks to provide, for example, super precise, accurate location information almost everywhere, which is by no means anywhere close to reality right now, and sensed awareness of the environments, right? And this applies not only to autonomous driving, but also other aspects of autonomous life. So that's kind of my view. There is a way to go, but there are certain things we need to put in place for this to happen, this revolution to happen. So,
thank you. Malik, what is your quick view on that, as we are running close to the time, to the hour? So
I think by no means I'm an expert on autonomous life, but certainly we are looking at how to leverage AI to drive autonomous networks. Most of our telecom networks are still manually provisioned. We still use a lot of element management systems, network management systems that's heavily run by human beings. So so the idea is that how do we take it to the more autonomous self-organizing networks? So that's what we are looking at.
very good, thank you. We are almost at the end, so I would always love to see the UCSD perspective on this, but what I can promise to everybody participating, that we will answer those questions to you and provide to people who ask some of the questions, as well as on this autonomous life. I think it's a very interesting topic where probably we should work all together as even panelists to figure out how we can communicate more. I think there is a lot of challenges ahead of us in this space, as we said, also, as Pascal was saying, we need universities to help us, and we need to give them data so they can do those mathematics and make our lives autonomous. So with that, Sujit, I'm handing over the panel to you, and thank you to all the panelists for participation.
Thanks a lot, Artur. Thanks, Malik, Babis, Bhaskar. Great panel. One of my takeaways from the panel, interestingly, is that we sitting on the university side, we always think about, well, how can we get data? I'm talking of wireless networks specifically. How can we get data? Yes, Open RAN, yes, ORAN. How can the industry help us get data, right? Real data. But what I gathered from this, and Babis, your idea was excellent. You pointed out the machine vision community. They went ahead and created their own data, right? Of course, in telecom, it's much more complex because for images and videos, it's much easier to create various kinds of data sets. This one is going to be very complex. On the other hand, I think many of you mentioned, including Malik, Artur, Babis, that we can create test beds in collaboration with our industry partners, which we are already doing, and we can gather data sets. And Artur, you mentioned in conjunction with the use cases, right? So we can look at use cases sometimes that you guys cannot look at. So we can also create a lot of data. The only issue is that our networks, however well the test beds we create, might not be reflective of the real networks. So that is a challenge, but would love to continue this discussion and follow up and sort of, one of my takeaways is that can we help in creating these data sets for the next several years in collaboration with industry, in collaboration with NSF and others. And that is something that, I think is going to be very important for the future of wireless research. Thanks to an excellent panel. Thanks to all of you. And so we are breaking for lunch. And the lunch will be till 12:50, and so we'll assemble at 12:50, and we'll have a very fascinating session where CWC directors will be looking back the last 25 years. It's just amazing that we have traveled 25 years. So we'll look back 25 years, and we'll try to look forward 25 years. That will be fun. Thanks, and see you all at 12:50.